Hi guys, today we're going to learn about differential equations. We have that dy dx is equal to x plus 3 divided by x squared, and we want x different than 0 and y of 2 is equal to 1 is your initial condition, and they want you to find the general solution and the particular solution. So what are you going to do here? The first thing, we need to separate your variables, okay? So this means that the dy needs to be with the y's and the dx needs to be first in the numerator and then with the x's. Therefore, what you are going to do is you do a cross multiplication, so you technically have dy divided by y plus 3, and this is going to be equal to dx divided by x squared. Now you ask yourself, are the y's, all the y's here? Yes. Are all the x's here? Yes. So you separate variables and we can integrate. You integrate this side and this side, okay? So the integral of this equation, you know that that integral is going to be natural log of absolute value of y plus 3. And on the other side, you have the integral of dx divided by x squared. That's going to be equal to negative 1 over x plus c, okay? Once you have this, you recognize that you have a natural log, which it's not ideal. Even though you can take this as your general solution, it doesn't look good. Therefore, what you're going to do is you are going to use the resources that you learn in Algebra 2. Basically, putting all this as the exponent of the e, what I do in my brain is I put the e, big e's here. So this is the exponent and this is the exponent. So you know that e and natural log, they are inverse functions. Therefore, what you end up having here is the absolute value of y plus 3 being equal to e to the negative x plus c, okay? But over here, I really don't like, and you're going to see in the future, that the e to the power of c is not a good notation, okay? So what we're going to do is I'm going to let c1 be equal to e to the c, okay? So this general solution that you technically have there, I'm going to convert it as y plus 3. Absolute value is going to be equal to c1 e to the negative 1 over x. And this is going to be the general solution that I'm going to use, okay? So with that being said, now you have your general solution, so now we can use our initial condition to find the particular solution, okay? So I have this check. Okay, I use my particular solution being y of 2 is equal to 1. This means that you have the point 2, 1. So you have that this is going to be 4 because I plug the 1 here, so you have a 4. This is going to be equal to c1 e to the negative 1/2, okay? So you can see that that equation, you can solve that c1 is going to be equal to 4 divided by e to the negative 1/2, but I do not like that exponent being negative. Therefore, the c1 is going to be equal to 4 to the times e to the power of 1/2 positive, okay? Because I use properties of exponents to convert this into a positive exponent, okay? With that being said, you know that the particular solution is going to be the following. The absolute value of y plus 3 is going to be equal to 4e to the, what was it, negative 1/2 times e to the 1/2, okay? So we don't like this notation because it has two bases of the same. Therefore, my particular solution that looks prettier, okay, or simplified, however you want to call it, is going to be e to the power of negative 1 over x plus 1/2, and that's going to be the particular solution, solution that we're going to use for this one, okay? And this is the one that I like the most. Now, to check your general solution, you can use the TI Inspire calculator, okay? And we're going to type the following idea, so you can see that it's pretty simple to find your and to check if this is correct, okay? So here's my calculator, so hopefully you can see it. If not, let me just put it closer to you. Okay, so we have that nothing, okay? So what we're going to put is DE, and then you're going to type solve, okay? Otherwise, you can also use your menu, and then I think it's in D that you have the differential equation. That would also work, but I don't know why I like this way better, okay? So you type the prime. This is going to represent pretty much the dy dx, okay? So you have that, and in this problem, what you have, let's put it together here, you have a fraction, okay, so control fraction, and you're going to have that it's going to be y plus 3, okay, so you have the plus 3 divided by x square, okay. After that, you're going to put the variables that you have in this equation is x comma y, and that's how you can get the general solution, okay. So look at that, we have exactly the same, okay. I hit enter, and then I have that my general solution for this equation is pretty much what we got. You can see it over there, okay. So you can see that it's pretty similar to what we have. Why we have this -3? Because pretty much what the calculator did is compare it with our general solution that we have here. Let me put it together. It took out the absolute value and passed it negative. That's the -3 that you see here, okay. So now for the particular solution, I'm going to copy the same situation, and what you need to do here is I would go here before the comma, and then I would type space, and then I would put and, okay. And when you type the and, after that you need to type your initial condition. In this case, my initial condition is y of 2 is equal to 1, so I'm going to type that exactly as it is. Okay, so don't worry if it messes up, so just erase stuff. So y of 2 is equal to 1, and then you need to put comma x comma y and hit your enter. Okay, so hit enter over there, and this is absolutely beautiful. Look at that equation, it's exactly the same one that we just got. Okay, as you can see, the -3 is different because the calculator just passed it subtracting to the other side, but it's pretty easy to see that your solution is the same. Okay. For the second problem, what you have is that given the differential equation dy dx is equal to 4x cubed y plus 20x cubed, and that y of 1 is equal to -3, we want to find the general solution and the particular solution. So what are you going to do? The first thing that you notice is that I cannot do separation of variables with this equation as it is. Therefore, what we need to do is we need to take out common factor. So if I take the common factor of these two terms, you can see that 4x cubed is the common factor. Therefore, you have y plus 5 as your equation now. And this looks much user-friendly, and I can do separation of variables with this equation. Okay, so what I'm going to do here, I have that dy divided by y plus 5, and this is going to be equal to 4x to the power of 3, and then you're going to have that it's dx, okay? So with this being said, what are we going to do now? Now you can integrate both sides of the equation. You can see that this is going to be the natural log of absolute value of y plus 5, and on the other side, you know that that's going to be x to the power of 4 plus c, okay? So technically this could be your general solution, but honestly it looks pretty bad because we have the natural log. Therefore, we're going to take and put the e on both sides of the equation. You know that this equation would look like it would be only absolute value of y plus 5, okay? And that would be equal to e to the x power 4 plus c, which you know that this also looks ugly, so I need to let my c1 be equal to e to the c, having your general solution as the absolute value of y plus 5 equals c1 e to the x power 4, okay? And this would be the general solution, okay? General solution. Now, what are you going to do with the particular solution? We're going to use the initial condition y of 1 is equal to -3, having your x as 1 and your y as -3. So what you have, you are going to plug it here. So when you plug the -3 here, what happens? You know that that's going to be a 2 is going to be equal to c1 e to the 1 to the power of 4, which is 1. So you know that c1 is going to be equal to 2 over e. Therefore, my particular solution would look like this. Absolute value of y plus 5 is going to be equal to 2 over e times e to the x to the power of 4. But honestly, this still looks ugly because you have two of the same kind on this side of the equation, which you can combine. So that's what I'm going to do. I'm going to combine it. Therefore, what you have is the absolute value of y plus 5 is going to be equal to 2 times e to the x power 4 minus 1, and that's going to be the particular solution for this problem. And that's pretty much it for this problem. Isn't that nice? So for this problem, what we have is we need to consider the differential equation dy over dx is equal to x over y. We need to find the particular solution y equals f of x to the differential equation with the initial condition f of -3 is equal to -1. And we need to state the domain. So here you need to be very careful stating your domain. Okay, so the first thing that you're going to do, obviously, is going to be do the actual separation of variables, which take you to dy times y is going to be equal to x dx. You see this equation and you can easily integrate both sides. Therefore, you have that it's going to be y squared divided by 2 is equal to x squared divided by 2 plus c. Following this idea, you can see that I can multiply everything times 2, having this as your general solution. Also, we could, technically speaking, say that your general solution is y plus minus the square root of x squared plus c. So this would be also a general solution that could happen for this equation, okay? So let's say that I took that one as my general solution, okay? Now, since we have, let me do a line here, since we have that f of -3 is equal to -1, I know what? Well, when you plug the y, which is a -1, do you agree that that's negative? Therefore, this must be the negative, okay? So you need to take from that one y equals negative root x squared plus c, okay? Why? Because this one you are going to equalize it to something negative. You know that the inside of the square root must be greater or equal than 0 from algebra 2. With this being said, you have that it's negative square root, and then you would plug here the -3 squared plus c, okay? Please remember that I use this one as my general solution, so I'm going to keep being consistent with that. So with that in mind, what do you have? Well, I would have that it's -1 is equal to negative, and you have that it's 9 plus c. Okay, so obviously I'm going to square both sides, having 1 is going to be equal to 9 plus c. Okay, so your c for this equation is going to be -8. So you have that your particular solution is going to be y equals negative root x squared minus 8 inside the square root. Okay, now what's the deal? This is your particular solution. Now you're going to tell me, okay, because I'm being consistent with what I have here. Okay, now you're going to tell me, hey, given that we have this as the particular solution, what's the deal with the domain? Well, the domain you need to be very careful. Why? X, could x be whatever? Technically speaking, yes, but no, okay? So you need to make sure that the x is not smaller than the square root of 8. And you need to make sure that, pretty much your domain, okay? So the domain of the particular solution, okay, is the following, okay? It's going to be x that is greater or equal than root 8, okay? And also x that is less than or equal than negative root 8, okay? Why? Because we need to make sure that this is positive, okay? Otherwise, you know that wouldn't fly for the square root function over there, okay? So this is the domain, okay? Now let's move on to the next problem. The next problem, you have that the rate at which a puppy gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the puppy is first weighted, its weight is 3 pounds. If P of t is the weight of the puppy in pounds and time t days after it is first weighted, then you have the equation dp over dt is equal to that 1/5 times 75 minus p. You want you have that y is equal to p of t be the solution of the differential equation with initial condition p of 0 is equal to 3. Now we need to use the separation of variables to find y equals p of t, the particular solution to the differential equation with initial condition p of 0 is equal to 3. Okay, so this has a lot of words. Okay, so before you get tired, we're going to use your equation dp over dt is equal to 1 over 5 75 minus p, and that one they gave it to you here. Okay, so I haven't done anything. After this, you will recognize, okay, I need to do my separation of variables. To do that, I need to have my dp here. Okay, put the 75 minus p on this side, and then the 1/5 you can leave it like that, and the dt here. I can integrate both sides, pretty simple there. Okay, so you can see here your beautiful natural log of absolute value of 75 minus p, and this is going to be negative, so there you go, the negative. It's going to be equal to t over 5 plus c. Okay, so since you have the negative there, I'm going to change it to natural log of 75 minus p is equal to negative t over 5 plus c. Okay, so you have this equation. What I'm going to do here is I'm going to do the e's, okay, that I did before. So I have that the absolute value of 75 minus p is going to be equal to e to the negative t over 5 plus c. You know that here I'm going to let my c1 to be e to the c. So I have that my general solution is going to be absolute value of 75 minus p is equal to c1 e to the negative t over 5. Okay, so you have this equation as your general solution. Okay, so with that being said, let's now do my particular solution. Okay, so we have my initial condition p of 0 being equal to 3. Okay, so what you're going to have is you know that p is 3, so you have 75. Okay, 75 minus 3, the absolute value is going to be equal to c1 e to the negative 0 over 5, which you know that that's 0. Okay, so you have 72 is equal to c1 e to the 0, okay, which you know that it's 1, therefore c1 is equal to 72. Okay, so here your particular solution, okay, it's going to look very beautiful. Absolute value of 75 minus p, absolute value is going to be equal to 72 e to the negative t over 5. Okay, so that's going to be your particular solution. Okay, and that's pretty much for this problem. Okay, I hope that you find this video helpful. Bye.